All right, so let's take a look at what Unit 6 says. So we're going to be looking at questions 1 through 8. We're going to start with similarity. Now, I know in the first semester, we talk about congruent. Remember, congruent, we even had a symbol. We had a symbol. Let me write this thing down over here. This might look something similar to you guys, something you guys are used to. And this is what we used to call congruent. Now, the equal sign, that meant same size. And this wiggly thing on top, that means same shape. So congruent was same size and same shape. Now we're going to be looking at what we call similar. For similar, the symbol we're going to use for similar is this one, which means same shape. So we're talking about figures that look the same, but they could be different sizes. Imagine on the movies, right? You guys go to the movies, you guys see the video, there's someone in the movies, but that person looks, obviously on the screen, looks very, very big. Now, in real person, that person is a lot smaller. They look the same, but they have different sizes. That's going to be similar. But there's two criteria that have to be met. For shapes, in this case, polygons, to be similar, two criteria have to be met. The first criteria is we're going to talk about same angles. So any angle that I have on the shapes, like say one of them could be smaller than the other, but my angles have to be the same. Okay, that's the first criteria. The second criteria we have to meet, I'm going to call this my sides. Sides are proportional. So let me write this. So the angles are going to be the same. So same angles and sides are proportional. I'll go over what proportional means. But these are the things that we have to meet. The same angles, the angles have to be the same, but the sides are proportional. It has to meet both criterias. If it only meets one of the two, not both, just one, then the shapes are not similar. Let's take a look at question number 1. Now, we learned back in the days that on polygons, two adjacent angles have to add up to 180. Right? We learned that. Now, if I see on the figure on the top, I see an 80 there. So I'm going to say this angle right here, it is 100. Two adjacent angles needed to add up to 180. So one of them is 80, the other one's 100. I see on my figure at the bottom, one of my angles is 110. I'm going to say this angle right here, it is 70. Now, the angles are not the same, so I'm not even going to check if the sides are proportional. I'm only going to say that this figure right here, let me call this not proportional. Let me see. State if the polygons are similar. I'm just going to say not similar. Right? The angles are not the same, so I don't need to check about sides. Now, what do I mean with sides being proportional? Let me go over that in question number 2. First thing, I look at the angles. I'm comparing the angles on the first figure with the angles on the second figure. Notice how some angles, they don't even have numbers, right? You guys see that they don't have numbers. They just have arcs. Some of them are with one arc and some of them are with two arcs. But I noticed that the angles are marked the exact same way on both figures. So the angles are the same. Like I said, I don't know exactly the numbers, but because they are marked the same way, I'm going to say the angles are equal. So far the first criteria is met. Now let's take a look at the second criteria. The second criteria, my sides have to be proportional. So let's see. Let me see what I mean with proportional. Now for proportional, let me look at my numbers. On the small figure, my numbers are 16. I'm going to see how many different numbers I can see. So 16, 18.8, and 32. right? I'm looking at the different numbers that I see. Notice I wrote them from small to large. Now, on the other figure, my numbers, again, from small to large, are going to be 20, 23.5, and 40. Okay, now for the size to be proportional, these fractions, notice I created fractions, they all have to be equal. Okay, so how am I going to check if they're equal or not? Simplify. Simplify the fractions. When you simplify the fractions, they should simplify to the same thing. All right, so looking at my first fraction, let me divide each of my numbers by 4. I have 16 over 20. Let me divide each of my numbers by 4. So that's going to give me 4 over 5. Okay, can I simplify more? I don't want to deal with the one in the middle just yet, because I'm gonna check on the last one. I'm trying to do the easy fractions first. In this case, let me divide each of my numbers by 8. Right, I'm gonna go 32 divided by 8, 40 divided by 8, and that's gonna give me 4 over 5. It seems like my fractions are proportional so far. Proportional means that when I simplify my fractions, they simplify to the same thing. Okay, so now let me check the middle fraction. Okay, I have to make this into a 4 over 5. Now, let me get in my calculator. Let me go 18.8 divided by 4. Okay, 18.8 divided by 4, and it gives me 4.7. Okay, so I found my scale factor here. Let me divide this by 4.7. Again, the way I came out with the 4.7, because I went 18.8 divided by 4. I chose 4 because that's the number on the top. So 18.8, let me divide each of this by 4.7. So 18.8 divided by 4.7 gives me a 4. 23.5 divided by 4.7, it gives me 5. So I simplified each of my fractions. Notice how they simplify all to the same thing. So sides are proportional. So the angles are the same. Sides are proportional. So I'm going to call these figures similar. Again, for me to call figures proportional, the angles have to be the same. Remember, that's the first thing that I checked. Number one, I checked my angles. They were not the same. So immediately said not similar. So angles have to be the same. Sides have to be proportional. All right, let's move on. Let's take a look at number 3. The polygons in each pair are similar. So I'm already told they are similar. Okay, by saying they're similar, I'm saying the angles are the same, sides are proportional. Find the missing side length. So that means that there's going to be a side that is going to be represented with a question mark. I want to know what's the value of that side. So what I'm going to do in algebra, last year we learned in algebra that when we don't know the value of something, we replace it with the letter. So the question mark, let me replace it with an X. So I'm going to solve for X. Okay, I called it X because I don't know the value of it. Now, because the sides are proportional, because the polygons are similar, the sides are proportional, I only need 2 values of each of my fractions. Okay, so 2 values on each of my polygons, I mean. So I'm going to use X and 8. I'm going to use the X and the 8. Notice how I circle them. So I'm going to say X over 8. I made a fraction. Now, X, on the other figure, X is going to go with 16th, and 8 is going to go with 34. So X goes with 16, and 8 goes with 32. Okay. Now, I can simplify these. I can make the second fraction with an 8 at the bottom. So I'm going to have X over 8 equals, now on this other fraction, let me divide each by 4 on the second fraction, because I want the bottom to be an 8. So let me divide each by 4. So that gives me 4/8. So here I'm just going to say, once I have the common denominator, I'm going to say x is equal to 4. Good. I found the value of x. X is equal to 4. Now, some of you might be telling me, Mr. Leonzo, I'm not that good at simplifying. Now, simplifying is not your thing. You struggle with simplifying. Let me show you another way how you can do this. Right? Because if you're good at simplifying, notice that I made the denominator be the same. Okay, so I made the denominator be the same, so I could just say x is equal to 4 because I'm comparing the top numbers. But again, if simplifying is not your thing, cross multiplied. Okay, so what do I mean with cross multiplied? I could have gone 32 times x, so 32x equals 16 times 8. So 32 times x is equal to 16 times 8. So 32 times x is just 32x, right? 16 times 8 on the other side is 128. To get x by itself, let me divide by 32. So 128 divided by 32, it gives me that x is equal to 4. So I've just showed you guys two ways how you guys can solve this question. Either simplify the fractions to make them look the same, or cross multiply. All right, let's take a look at question number 4. That question mark, I'm going to call it x. So I don't know the value of it, so I'm going to call it x. The two numbers I'm going to use from that polygon are going to be x and 24. Again, because the polygons are similar, I only need two values per polygon, per figure. I don't need to use all the numbers given. I only need two values per figure. Okay, so let me make a fraction. X over 24 equals, now this x goes with this 10. So this other side, let me write a 10. And 24 goes with 16. I can either simplify them so my fractions look the same, or I can just cross multiply. Now, probably simplifying is not the best way to go always. So I'm just going to cross multiply. Let me go this way. 16 times x, 16x. 24 times 10 is 240. Now to get the x by itself, let me divide both sides by 16. Right, I divide by the number in front of x. So x is equal to 240 divided by 16 is 15. Okay, now one thing here, because I'm doing it on paper, well, I'm writing it down. Notice how my answer I wrote x equals a number, right? X equals 4 or x equals 15. When you type in your answer, you don't have to type in x equals. Remember, it was a question mark to begin with. You don't have to type in x equals or the question mark equals. Just type in the number. So if I was doing question number 3, for my answer, I would just type in 4. I don't have to type in x equals 4, just 4. For question number 4, I don't have to type in x equals 15, just 15. All right, let's take a look at question number 5. I'm going to be working up until number 8, by the way. So let's see. Let me. Not letting me move. There we go. All right, so question number 5. Solve for x. The polygons in each pair are similar. I like that phrase. The polygons in each pair are similar because that tells me the sides are proportional. So I'm just going to create two fractions and then they're going to be proportional. So I'm going to be able to cross multiply it or simplify. All right, so for one of my figures, I'm going to use this value because I'm solving for x. I'm going to use 3x minus 6 and 15. So let me go 3x minus 6 over 15. I created my first fraction. Now 3x minus 6, it's corresponding with 30. I'm just going to write it there. 15 goes with 25. And I'm going to cross multiply. Now, one thing, probably you don't want to deal with big numbers, right? Notice how when I cross multiplied 15 times 30, but then when I cross multiply 25 times 3x, 25 times 6, you can make your fraction smaller, right? 30 over 25, we could simplify that. Let me divide each by 5. So I'm going to call this, instead of 30 over 25, let me call this 6 over 5. All right, my numbers are a little bit smaller. What I did is I divided each number by 5, right? I simplified a little. Now, if you don't want to simplify, you immediately just want to cross multiply it. You don't have to simplify. I'm just simplifying just to deal with smaller numbers. Okay, so now let's go this way. When I multiply this way, because there's a minus, right? When there's a minus or a plus, the number that is by itself, in this case 5, I'm going to multiply to the other two numbers. So 5 times 3x and 5 times 6. Every time there is a plus or a minus, the number that is by itself gets multiplied to the other two. So I'm going to have 15x minus 30 equals. Notice how I went 5 times 3x and 5 times 6. I kept the minus. Notice how I kept the minus. So 15x minus 30 equals, and then this way, 15 times 6 is 90. Okay, so I want the x by itself. Now let me show you guys a trick. I know before, you guys were told opposite operation, that where we're gonna get rid of the minus, we're gonna do plus on both sides. But let me show you guys a shortcut. This is gonna be really simple. Now, let me do the long way first. People will say, okay, let me add 30 to both sides to cancel this. Remember that? We did that before. That's the long way. Now, let me show you guys the short way. I said I'm going to show you guys a trick. What I'm going to do, this minus 30, let me cancel it because my goal is to cancel it. My minus 30, let me move it to the other side as a plus 30. Don't forget to switch the sign. In reality, we're doing the same thing. Okay, so now I have 15x. That's what I have by itself. 90 plus 30, that's 120. And then to get the x by itself, let me divide by the number in front of x. So let me divide both sides by 15, because that way 15 divided by 15 is 1x. So I'm just going to write x there. Now 120 divided by 15 is 8. So x is equal to 8. Again, when you guys type in your answer, you don't have to type in x equals. I'm just expecting 8. Let's take a look at question number 6. From this polygon, let me circle the two values that I'm going to use. Negative 5 plus 2x over 18. Negative 5 plus 2x goes with 10. 18 goes with 12. I can simplify 10 over 12. I could just call it 5 over 6. Right? I can simplify, but what if you don't want to simplify? If you don't have to simplify, you're going to deal with bigger numbers, but you don't have to simplify here. So let me cross multiply. 12 times a negative 5. All right, 12 times a negative 5 is negative 60. And then there's a plus sign. 12 times 2x equals 18 times 10. Okay, so I have the negative 60 plus 24x is equal to 180. I want the term that has the x by itself. So this minus 60, I'm going to move it to the other side as a plus 60. Don't forget to switch the sign. So that gives me that 24x is equal to 240. Right? 180 plus 60 is 240. To get the x by itself, let me divide both sides by 24. So I get the x by itself. 240 divided by 24. Use a calculator if you need to. 240 divided by 24 is equal to 10. So x is equal to 10. And again, you don't have to type in x equals, just 10. Now, let's move on to our last two questions. I remember that back in the days when you guys were dealing with congruent triangles, remember there were a few rules that work. Side, 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 angle, 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 side, angle. Remember those rules? There were a few rules that work for congruency when the triangles are the same shape, same size. Now, for similarity, when the triangles are similar, there's only a few rules that work. One of the rules we're going to be using is side, side, side. So let me just go side, side, side. That's one of the rules. The other rule that we're going to be using is side, angle, side. And then the third rule, I remember one rule that did not work when you guys were dealing with congruent. Remember, you guys talk about angle, angle, angle. That one didn't work for congruency, but it does work for similarity. So for the moment being, let me call this angle, angle, angle. When the three angles of one triangle are equal to the three angles of another triangle, we're going to say that triangles are similar. Now, one thing, two triangles is enough, right? Angle, angle, angle. If two angles of one triangle are equal to two angles of the other triangle, the third one is equal as well. So we're going to say two angles is enough. So we're going to call this angle, angle. Now, when I'm using angles, the angles have to be equal, okay? The angles have to be equal. If I'm using sides, the sides have to be proportional. Okay, so remember proportional, I mean that if you simplify the fractions, they simplify to the same thing. If simplified is not your thing, you can cross multiply. Now here, question number 7. I don't see any numbers at all. I only see two sides that are parallel. One thing I remembered is that if I had two lines that were parallel and I had a side that crossed them, I remember this rule that we called corresponding angles. And then we used to say that corresponding angles were equal. Now I'm looking at my two parallel lines, but I'm looking at this side, I'm lining up as my transversal. So matter of fact, let me extend my lines here. I see my two parallel lines and I see my transversal. And based on the rule of corresponding, I can say this angle is equal to this angle. I don't know exactly how big they are, but I know those two angles are equal. Okay, let me clear this up. So I marked those two angles. Like I said, those that I marked, I'm going to say they're equal. I still remember the corresponding rule, but now I'm going to see it this way. Let me look at it this way, like here. I'm going to say this angle, I'm going to do it with two arcs because it's the second angle that I marked. This angle is equal to this angle. Let me erase these things right here. Okay. If you notice, there's two triangles that I'm looking here. Let me highlight one in blue. Do you guys see that one? And let me highlight one in red. You see it. So there's a blue triangle and there's a red triangle. They're different sizes, but for similarity, that's okay. My angles are equal. Two angles of one triangle are equal to two angles of the other triangle. So I'm going to use the rule angle, angle. Now, when the rules are, when the triangles are similar, first of all, here it says, state if the triangles in each pair are similar. Okay, I'm saying they are. I'm saying they are because I have a rule, right? Angle, angle. So, if they're not similar, I would just write not similar. So if they were not similar, I will just come in and I will type in not similar. If they were not similar, okay? If side, 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 or angle don't work, type in not similar. Notice how I capitalized my N for not, but not the S for similar. Remember in your English classes, they ask you to capitalize the first letter when you guys write a sentence? Same thing here, okay? Capitalize the first letter. But in this case, they are similar. So if so, I'm still reading here. If so, state how you know they are similar and complete the similarity statement. So LMN, if you notice, that's the red triangle. Remember I said there's a blue triangle and the red triangle? LMN is the blue triangle. So let me complete it, the red triangle, so let me complete it with the blue triangle. The order of the letters does matter. So L, S, R. All capitalized, all right? Triangle LMN is similar to triangle LSR. Now, one thing, order of the letters matter. Notice how my second letter is M, and then here S. Look at angle M and angle S. They're marked the same way, right? So order matters. Look at angle N with angle R. That's the third letter. So I'm going to say LSR, but then I have to say by which rule. So I'm going to say by angle, angle. Big emphasis on how we type the answer. The three letters, the LSR, have to be capitalized. The rule, angle, angle, has to be capitalized. The word by in between, it doesn't have to be capitalized. Don't forget, it sounds silly, but I've seen it so many times. Don't forget only one space in between words. So there should be one space here and one space here. So LSR space by space angle angle. Again, if the triangles are not similar, just write not similar. If they are, complete the statement, but the statement I'm stating which triangle and which rule am I using. Okay, so let's take a look at here. Now, I see a red triangle. And I see a blue triangle. Now, from the red triangle, I only see the measurement of two sides. I'm going to say 45 and 81. From the blue triangle, I see the numbers 25 and 45. Notice I went from small to large. Looking at the red numbers, 45, 81, I listed those from small to large. And then on the blues, also from small to large. Okay, so if we're good at simplifying, simplify the fractions and hopefully they simplify to the same thing. Now, if simplifying is not our thing, let's cross multiply it. Now, 45 times 45, if I go this way, 45 times 45 is equal to 2025. And then this other way, 25 times 81, use a calculator if you need to, it gives me 2025. When my sides are proportional, and I cross multiplied, I get the same thing. Okay, so the sides are proportional. I have two sides. Another thing that I remember the vertical angle theorem. Remember, vertical angle theorem stated, you guys saw this before, when there's an X formed, opposite angles are equal. So I'm going to say this angle, it's equal to this angle, right? When there's an X formed, opposite angles are equal. Don't know exactly how big they are, I just know they're equal. So it seems like I have two sides and the included angle. I have the angle in between. So that looks like side angle side. So I had to complete this statement. RQP. First of all, let me say that this angle is going to go with this angle. And this third angle, I'm going to see what angles go with what. I'm marking the other two. I'm going to use side angle side, but I marked the other angles as 1, 2, and 3 just to know what angles go with what. So RQP is the red triangle. I'm going to say it's similar to R, because notice the one angle with the one angle that has a one arc with the one arc. Now my question is, do I go RUT or RTU? Gotta think. Order matters. RUT or RTU. The second letter is Q, right? On the red angle, it's angle Q. That is marked with two arcs. So then I'm gonna say RTU by side angle side. Let me zoom out so we can see what we worked today.